Hello everyone, it's Wilson here. Today I want to talk about this integral here. And you can see that this integral is a rational function. So we usually are going to use partial fraction decomposition to decompose the rational function so that we can integrate, right? And this function, as you can see here, looks so simple, but it turns out that it's going to be a lot of work, and it would actually be a really good learning example for the technique of integration by partial fraction decomposition, because it reveals a lot of details when you are in the process of integrating it. Okay, so let's get started. So first, we have to factor the denominators. Okay, so that we can decompose the function, right? So the first thing is that we need to rewrite this integral as 1 over. Now, regarding the denominator here, we need to think about how to factor that. And as you can see, the x cubed is a perfect cube, and then the 1 is also a perfect cube. So in that case, what we are going to do is that we're going to just recall a formula right here that will allow us to factor the difference of two cubes. So let's try that. So the formula that we have, let me just recall that right here. So let's just recall that formula. So in that case, that's going to be a cube minus b cube. That's the difference of two cubes. How do you factor that one? It would be a minus b, and then times a square plus ab, and then plus b square. Okay, and so you can see that this sign is the same sign as that one. So there was a minus sign, there was a minus sign right here, and then what you're getting here, it's almost like the perfect square, except that we don't have a 2, so that's not really a perfect square. That cannot be factored into a plus b quantity square because we're not having a 2 here. But that's not our main concern here, right? Because we just want to factor this a cube minus b cube equals this one. And there is actually one easy way for you to remember the signs regarding like how to put those signs. You can actually use what we call the SOAP. Okay, you may say, what is that, right? So the SOAP means the same sign, right? Actually, let me use a different color so that it's easier to see. So the S stands for the same. So same sign, and then opposite sign. So we put the opposite sign right here. So same sign as this one, okay? And then this one, of course, will be the opposite sign, right? Opposite sign, and of course, that's also it's based on whatever sign that you have between the two cubes. So that's opposite sign, and then the AP stands for what? AP stands for always positive. Okay, so always positive. So that's actually an easy way for you to remember this. Okay, so now we can factor this x cubed minus 1. And so you can see that the x is actually the a here, and then the 1, the b is actually the 1 here, right? So you can factor as a minus b. So we are going to be getting, so we have x minus 1, okay? And then now it says a squared. Remember, a is x, so you get x squared right here. Now plus, now what about the AB? The AB is really just multiplying the A and the B together, so x times 1, so you just get x. Then plus, now the B squared. B squared is what? Just 1 square, so just get the 1. And then so you get the dx right here. Okay, so we factor that. And then the next step is to decompose this function, right? So we are going to write it like this. So let's just write it down here first. Then you're going to be getting x minus 1. Then we have x squared plus x plus 1. And then we can write it as, so as you can see, this x minus 1 is a linear factor, so we are just going to put a single constant on top of that, right? So you're just going to get, let's just use a. So a over x minus 1, and then plus. Now for this second one right here, this is x squared plus x plus 1, right? So this is an irreducible quadratic. So you can still factor it, but you can only factor it over the set of complex numbers. So you cannot factor it over the set of real numbers. So in this case, we are going to just put bx plus c. Okay, so we are going to put a linear expression at the top of this expression. Okay, so that's our form of the decomposition. So now you may say, what's next then? So the next step is to clear the fractions so that we only need to worry about working with the numerator. So the way that we do that is that we are going to write down the LCD right here. The LCD is actually easy to determine. It's basically just the original denominator. Okay, so we are just going to be writing down x minus 1, and then x squared plus x, and then plus 1. Okay, so far so good. Yeah, so it's always the same thing as the original denominator, so we don't even need to try too hard to figure it out. Okay, so now we multiply every fraction of this equation by the LCD. So as you can see, when you take this left-hand side of the equation, you multiply by the LCD, the x minus 1 get canceled, the x squared plus x plus 1 also get canceled, right? So you are just left with just the 1 on this side. Okay, now what do we have on the right hand side? Now you can see that the x minus 1 will get canceled, and so you're left with the a in the numerator and also the x squared plus x plus 1 in the numerator. Okay, so we have a and then times x squared plus x plus 1. And then continue. So we have bx plus c. And then we can cancel the x squared plus x plus 1, right? Then we are left with just the x minus 1 multiplied by the bx plus c. So we just have x minus 1 here. Okay, so now we have this equation, and this is I usually just start this equation here because this is the important one that we are just going to work with, right? So I'm just going to put box here, and then I will just put a star, right? So this is the star equation. Sometimes I will need to refer back to this equation here. Now, usually the way that we do this is to just plug in some x values, which will make it easier for us to define the coefficients, because when you choose an x value, you are supposed to be choosing some values that will make the terms disappear. Okay, so the easy one, right, is to just plug in a 1 in here, because 1 minus 1, you get 0. So this term is going to disappear. And then you're left with just this term so that you can figure out the a already. Okay, so first step. Let's let x be equal to 1. Okay, so now then what do we get here? Then we are getting this equation. The left hand side is just a 1 right here, so we just get a 1, and then the a is there, right? And then now you put the 1 into all the x's that you see, so you get 1 here, and 1 here, so you get the 3. I'm just going to show the work right here. So 1 squared plus 1 plus 1, right? And then plus, well, when you plug the 1 here, you are going to get 0. So you know that it's just going to be adding 0, right? I don't really care what that looks like, because after you calculate this, you multiply by 0. So just get 0 here. So simplifying this equation, you're going to be getting what? You're going to be getting 3a is equal to 1. Okay, so I switch the two sides. I just get the variable on the left side. So I have a times 3. So I get 3a equals 1. And so as you can see, that it's actually easy to figure out the answer. So a is equal to 1 over 3. That okay? So far, that's actually not too bad, right? Okay, so now the next step. the next step is to, you have multiple choices right here. You can just multiply everything out, okay? Or you can simply just plug in another number so that you can, hopefully, you can figure out the b and the c. But of course, if you just plug in another number right here, then that may not be, you still have an equation with two unknowns, the b and c as the unknown right here. But it depends. So I can simply just plug in a 0, because when I plug in a 0, the b term will disappear. So that will probably just allow me to find c quickly. So I'm just going to pick a different number. So I let x be 0. So another reason for picking 0 is because it's an easy number for the calculation. So we then have 1 is equal to, okay, so now the a is already figured out, right? It's 1/3. So we are going to get 1/3. And then we have, now if you plug in the 0 into all the x's, you're going to get 0 plus 1. So you just get 1, right? So I'm still just going to show the work right here. Plus, okay, so you plug the 0 in here, the b term will disappear, so you're left with the c. So you just put the c here, and then if you put in the 0, you're going to get -1. Do you see that this equation only has one unknown right here? So that's actually a good thing, right? So we can solve for c. So simplifying this equation, then you're going to get -c plus 1/3 is equal to 1. So if you just keep going, then you are going to be getting, so -c is equal to 2/3. So c is equal to -2/3. Is that okay so far? So that's good. And then now it's really up to you what you want to do to figure out the b. But all we need to do is to, we can simply just plug in the a and the c back in, and then just choose another number to plug in, which will be nice. Okay, so I can choose a number like x equals, let's say 2. Okay, then what do I get here? I get 1 is equal to, now a is 1/3, so I'm just going to get 1/3 here. And then I plug in the 2 in there, so I get 4 plus 2 plus 1, right? I'm just substituting the 2 into all the x's that I'm seeing. And then plus, now the b is unknown, right? So you get b times 2. Well, actually, I can just put 2b. And then c, don't forget that it's actually just -2/3, so -2/3. Then you may say, what about this thing? 2 minus 1. I picked 2 because I want to just make that a 1 so that I don't need to do too much of the multiplying out, right? So I just get 1, right? So I have this equation. Now continue to simplify this equation. Then we are going to get 1 equals. This is what? This is 4 plus 2 plus 1. That's 7. So 7/3. And then plus 2b minus 2/3. So you can see that that's going to be 1 equals 2b, and then 7/3 minus 2/3, we can get 5/3, right? So 5/3 plus 2b. Yeah, so continue with the calculation. We can move the 5/3 to the other side, so I get the 2b. I'm switching the equation at the same time. So we are going to get -2/3, right? Yeah, 1 minus 5/3 is -2/3. So now you divide both sides by 2. Then you get the b, 2b, just -1/3. So we have figured out all the constants, the ABCs, right? So we have figured out all the constants right now. So now what do you want to do? So we can plug them back in, and then we can start integrating this. Okay. So so we have the original integral. I usually will just give it a new name and call it the w, right? But right now I'm just going to use, okay, so just write the original integral. I don't want to write down the original one. But then what do we get here? We just put 1/3 over the x minus 1, right? So you can put that's equal to 1/3. Well, actually I need the fraction line, right? So we have x minus 1 dx and then the integral. Okay, so now the bx plus c. So what do we get here? We have -1/3 x plus the c. The c is -2/3, so I need a minus sign, so -2/3. Okay, and then we have all that x squared plus x plus 1, and then the dx. Yeah, so now we have this new integral here. It would be a good idea to try to simplify the integrals first. Okay, so if we do that, then we can pull out the constant, right? So we pull out the 1/3. So we are going to be getting 1/3 integral of 1 over the x minus 1 dx. And then now this, for this numerator right here, we can factor out -1/3. Okay, so we can factor out -1/3. And we have the integral, which becomes x plus 2. Okay, if we factor out the -1/3. Then we get x squared plus x plus 1, and then the dx. Now you can do a quick check. It's -1/3 times x, so we get -1/3x. -1/3 times 2, we get -2/3. So we have done the factorization correctly. Okay. Now I would say that this one is actually easy to integrate, as you can see, right? This is just uh, a linear expression in the denominator, so we're just going to get Ln of absolute value of x minus 1. So that's that one we don't need to worry about. The only one that we actually need to worry about is this one right here. Okay, this one you may say, what do we do, right? We are going to be using trigonometric substitution after we complete the square. Okay, so this is the one that we need to focus on right now. Yeah, so we got to focus on this one here. Yeah. And then you may say, what about the -1/3? We can just put it at the end, right? Once we get the result. So now just focus on this integral here. So let's continue. Okay, so we have this integral, which is x plus 2. And then we have that x squared plus x, and then plus 1. Okay, how do we complete the square? Okay, how do we complete the square? Yeah, let's do the step of completing the square first. So let's complete the square. For the denominator, I'm just going to not write it right now. So let's look at this. So we have x squared plus x plus 1. And so how do we complete the square? It's this. So you know that we are going to be taking this coefficient of the linear term, which is 1 in this case, right? We are going to just divide by 2, so you get 1/2, and then you square it. That's what you add to complete the square. So you are going to be getting plus, and then you take the 1, right? You take the 1, and then you are taking it, dividing by 2, and then you're squaring it. That's what you add to this expression. Now the 1 is still there, right? The plus 1 is still there, so I still got to put it there. But then I cannot just add something to my expression. I will be changing it, right? So I need to negate the effect that it has. So I need to subtract it back. So now we still have the original expression because basically we're adding 0 here. So from here, let's continue. We are going to be getting x squared plus x plus 1 over 4, right? And then we can actually put those two together, which will give us, now if we put this 2 together, that will give us what? Plus 3 over 4. Then you may say, how do we know that we are getting 3 over 4? This is 1/4, right? 1 minus 1/4 gives us the 3 over 4. So now this blue portion right here, it's the perfect square, so we can factor it. If we factor it, then we are going to be getting x plus 1 over 2 square, and then adding the purple part. If you want, you can simply just also write it as a square form, which looks like square root of 3 over 2, and then the whole quantity square. Okay, so we are actually ready to go with the tricks up. And so you know that this integral actually will turn into that, right? So let's do that. So I actually will just use the regular white color here. So it will be x plus 2. And then we have what? We have this whole thing right here. So we get x plus 1 over 2 square, and then plus, and then this purple part right here, right? So you get the square root of 3 over 2, and then square. Then you get the dx. Okay, so you may say, what do we do next? We are going to start our tricks up. So let's do the tricks up right now. So we're getting the tricks up. We are going to let x plus 1 over 2. You can do a user first, but it's unnecessary actually. It would be what? It would be a tangent, right? Because there was a plus sign right here. So we are going to get x plus 2, x plus 1/2, and then equals this square root of 3 over 2, and then the tangent. That okay so far? So now what do we get here? We need to find the dx as well, right? Because we got to replace that, right? So if we take the derivative of this equation on both sides with respect to data, then we are going to be getting dx. As you can see, because there is the coefficient of 1 in front of the x. So when you take the derivative, it becomes a 1, and then the 1/2 will disappear. So that's why we actually don't even need to make another use up for that. So just take the derivative of this, which will give us the square root of 3 over 2, and then secant square data d data. But at the same time, because we need to make some more substitution like right here, so it would be a good idea to also solve for x, because I need to put some expression for the x as well, right? So we can write that right here, which will be solving for x. So you get square root of 3 over 2 tangent theta, then minus 1 over 2. So now we have that expression. So we put all those ones in here. Okay, so we are ready to go back to the integral. So continue with the integral here. Then what do we have? X replaced by this expression right here. So you're just going to be getting radical 3 over 2 tangent theta minus 1 over 2. But then don't forget that there is still the original plus 2 right there. So now what about the bottom? The bottom, it's this blue portion right here is going to be replaced by the radical 3 over 2 tangent theta. So you're just going to get radical quantity square plus, okay, this thing just there, right? And then don't forget that there's still the dx that you need to put in. So you got to put the dx right here. Okay, now it looks like it's super messy, right? But we can just simplify step by step right now. So all we need to do is step by step. It's just in general, it's a lot of work, but it's okay. Okay, so let's continue. Okay, so what do we have here? We can simplify the top, which would give us the radical 3 over 2 tangent theta, right? And then plus this thing right here is 2 minus 1 over 2. So you are going to get 3 over 2. Now, what about the denominator here? You can see that if we simplify, then you are going to be getting 3 over 4 tangent square theta plus 3 over 4. Now also this thing right here, just leave it, right? So you're just going to get radical 3 over 2 secant square theta d theta here. Now I just want to show you that if you look at this right here, if you factor out the 3 over 4, right? So let's just look at this portion on the side. We just look at this portion on the side, we factor out the 3 over 4, then it actually becomes tangent square theta plus 1. And what is tangent square theta plus 1? It's secant square theta. So you're actually just going to get 3 over 4 secant square theta. And do you see that 3 over 4 secant square theta is supposed to be here? So you can actually cancel the secant square theta together, right? So I'm just going to show it in the next step here. I think I scrolled too fast. Yeah. Just slowly. Okay, now that's better. Okay. So we are going to be getting what? The integral. Okay. Now, we can just keep copying the other stuff, right? So just get radical 3 over 2 tangent theta plus 3 over 2. And then all over that 3 over 4 secant square theta in the denominator, right? That's what we did here. And then we still have that, right? The dx portion. So radical 3 over 2, and then secant square theta d theta here. Isn't that a good news right here? Because you can see that there was a secant square theta at the bottom, there was a secant square theta at the top, so we can actually have them cancel. So we are going to be getting what? So we can cancel them. And then also we can cancel out more stuff. Like there was a 2 in the denominator, there was a 4 in the denominator, right? So you can actually cancel out this 2 and the 4. So the 2 and then the 4 becomes a 2 right here. And then you can just make the radical 3 go with the top, which will simplify some of the calculation at the top right here. Okay, so we do that, right? Then you are going to be getting, okay, so you can distribute this radical 3 to that one. Radical 3 times radical 3, you just get the 3, right? So you get 3 over 2. So you get 3 over 2. And then the tangent theta, okay, plus, okay, now what do we have here? Multiply that by the 3 over 2. So you're going to get 3 radical 3 over 2. Okay, so the numerator is done, right? The other stuff got canceled already. What do you have in the denominator? Just 3 over 2. Okay, so just 3 over 2. And then there was this d data right here. That okay so far? Now we have two terms. There is a constant, so you can break up the integral into two right now. So you are going to just take this first term divided by 3 over 2. The 3 over 2's will cancel, so you get the integral of just the tangent data, d data. Now plus, now take this number divided by this number. The 3 over 2 will get cancelled. You are going to just get the radical 3. And then the d data here. Now, looks pretty simple, right? And then we can integrate tangent directly. We can also integrate radical 3 easily, right? So we are going to get ln. The antiderivative for tangent data is ln of secant data plus the antiderivative for constant is just that constant times the variable of integration. And then that's not finished yet because we need to switch back to the variable x, right? Because we make the substitution to switch from x to data. So right now, to do that, we actually need some information to write an expression for secant data. The data is easy to write, right? All we need to do is to solve for tangent right here. So going back to the substitution that you see here, we gotta make a triangle. Okay, we gotta make a triangle. So from here, right? Also coming back from this one, then you are going to get what? You have x plus 1 over 2 is equal to radical 3 over 2 tangent data. And then we should be solving for tangent in this case. So, so that we can draw a triangle. So if we solve for tangent, then we are going to take this x plus 1 over 2, right? And then we divide by the radical 3 over 2. So we are going to be getting x plus 1 over 2 all over radical 3 over 2. And if you want, you can simplify a little bit more, which will give us, well, actually, I can just keep using equal signs, right? Because it's still tangent equals to this thing. So I multiply the top and the bottom by 2, okay? So I'm just going to get 2x plus 1 over radical 3. Yeah, so again, multiply the top and the bottom by 2, so I get this. Is that good? So tangent data is equal to this thing. So that means we can draw a triangle. So let me just draw the triangle on the side right here. So this is the data that we would be looking at, right? So it would be the opposite, right? Opposite of data. So we get 2x plus 1 over the adjacent. So you get square root of 3, okay? And then based on the two legs, right, we can write down the hypotenuse using the Pythagorean theorem, which would give us the square root of simply just the square of this thing plus the square of that. So you're just going to get 2x plus 1 square plus 3 because you got to square this, the square root of 3, so you get that. So let's continue. We're ready. So we can write an expression for secant data, which is the hypotenuse over the adjacent, right? So you are going to get ln of absolute value of this thing. Okay, so 2x plus 1 square and then plus 3. Okay, so far so good. And then all over the square root of 3. And then plus square root of 3. And then you may say, what about the data? The data is really just the arctangent of this thing, right? So you're just going to get tangent inverse of 2x plus 1 over square root of 3. So we got all that expression right now. Okay, but that's not finished. Remember, we were only doing what? We're only doing this integral here. So we still got to go back to the original integral and then write down all those things, right? So it will be 1 over 3 and then integral 1 over x minus 1 dx and then like the 1/3 times whatever result that we just got. Okay, so let's go. So coming back here, the original integral is equal to, what do we have here? 1 over 3 integral of 1 over x minus 1 and then minus 1 over 3. Now we got all these expressions right here. Remember, we focus on doing this one. Right, we focus on doing this one. This one goes right here. Yeah, so that would be ln of the square root of 2x plus 1 square plus 3 and then all over square root of 3 and then plus the square root of 3 tangent inverse of 2x plus 1 over square root of 3. That's all that stuff. Is that okay? And then there was a constant of integration, so we got to use k right here. Okay, we still need to integrate this, right? And then maybe simplify this. So we are going to be getting 1 over 3 ln of absolute value of x minus 1. Okay, so that one is easy to integrate. So that's the antiderivative. Now distribute this like the 1/3 to everything in here. So you're going to be getting like the 1 over 3 and then ln of this 2x plus 1 square plus 3 and then square root of 3 and then minus square root of 3 over 3, right? Because we still don't forget to distribute that with this thing. And then we have the tangent inverse of 2x plus 1 over the square root of 3 and then plus the k. Right, so that's really just the final answer here. Yeah, if you want, you can expand this one and then multiply out and then probably just put the two square roots together and then continue, right? But because everything is inside the square root, so we are assuming that this is a positive quantity, so we don't even need the absolute value. But here, I'm not going to do that extra algebra work. If you want to do that, you can just try it and play with that. Okay, so that's it for this problem. To help me make math learning available to everyone, please share my videos to others and subscribe my channel. It will give me support to make more videos. Let's work together to help students and children learn math more